Okay, folks, so this is about double saloon door tectonics on the East African Rift. Before I move to that, I want to just mention something else, which is about rifts that propagate towards poles of rotation. So up here, if we have continent west and continent east with this motif, and if they start to rotate about a pole to the north, they move more here than they do here. If orange indicates rifted continental crust, X is the extension, which is critical, beyond which point you would have oceanic crustal emplacement here shown in blue. And if we rotate further, X moves north, the entire oceanic rift propagates north, and this isochron centrally placed here becomes this one, abutting rifted continental crust. And this was all about the South Atlantic. There's Africa. This is rifted continental crust. These magnetic anomalies are seafloor spreading anomalies, and they indicate a northerly propagating rift. So this was an early point where I went, aha. But like I said, it was early, so I've put the light bulb above Australopithecus here rather than Homo sapiens. Moving on, if you have opposite rotations, and this was motivated by Southwest Gondwana reconstruction, if you have West 2 rotating away from West 1 about this pole, that's the propagating rift propagating towards the rotation pole there. Same happens this side, but you end up with a rift between West 2 and East 2 as well. And normally those opposite rotations occur at a subduction zone. And the analogy is double saloon doors as with a cowboy entering the bar. Now, this wasn't so much a light bulb or a moment. It was more of a W2F moment. Why does that happen? Anyway, later, I was working in Libya and realized that you have opposite rotations, for example, of the Balearic Peninsula versus Sardinia, Corsica. And you also get it in the Betics of Spain and the Rif of Morocco. It happens also in the Calabrian Arc. And if we expand a bit, it happens in the Carpathian Mountains, and it occurs in the Hellenic Arc. Now, this is slightly, all of these opposite rotations related to subduction rollback. So this time I put the light bulb above Homo habilis rather than, because we're evolving in our thinking. So moving on to the East African Rift, you guys and girls all know where we extend from, afar all the way through here. And the area we're interested in is this central bit here, including Kilombero Rift. So if we look at seismicity, schematically shown by these red dots, it outlines the African plate, but it can be divided into Nubia in green and Somalia in blue, as Anne just showed a moment ago. And we have the Victoria microplate, Rovuma, Lowandle here in dark blue, and this orange area is a zone where Somalia is moving right laterally relative to Lowandle. Why is it interesting? Because these two rotate in opposite directions. So again, if we look at Africa here, and the blues are the East African lakes, Eocene to Oligocene volcanics in magenta, Neogene ones in purple, and recent volcanoes in red triangles like this. And all of this started about 45 million years. And we have a nice progression of ages from 35 down to modern times along the eastern branch, indicating a southerly propagating rift. And in fact, that is the orthodox view. And that is partially supported by data on this side. These are age dates, isotopic ages, and partially by earlier dates recorded at Rungwe here. But then high quality dates were also recorded at Rungwe that go all the way back to 26 million years. And obviously that is older than here at Mwenge Kamatura. So that kind of negates the overall southerly progression or propagation model. So let's look at issues that have been suggested indicating propagation. So first of all, those isotopic ages. And if we have 26 million here at Rungwe going to between 6 and 3 million here, obviously that would suggest northwest propagation. Between Virunga and here, we may have southerly progradation in this segment, and again northerly between Virunga and Torreancole here, according to isotopic ages. If we look at border fault throws and subsidence and sediment thicknesses, a criteria suggested by Ebinger et al. In 84 and 87 to show southerly propagation of the Malawi Rift, applying that, we would get westerly propagation in Rukwa and a mixture of northerly and southerly on Lake Tanganyika. If we look at lake sediment ages in Rusizi, they are older than those in South Kivu. Again, it would suggest northerly propagation in this section. Rift geometry and numerical modeling have suggested opposite rifts around Rwenzori, as shown here in purple, and then finally, carbonatite volcanic complexes suggested to Rosenthal et al. That you may have a northerly propagating rift, as shown here between Bukavu and Torreancole. Overall, there are 7 indicators of northerly propagation and 3 for southerly propagation. This is just a quick review of what is thought to occur around Rwenzori Mountains, whereby the Semliki Rift may propagate that way, Lake Edward, Lake George rift propagates this way, and these reds here are the Torreancole volcanic zone that we mentioned earlier. And it is akin to oceanic spreading ridges that sometimes propagate in opposite directions, as shown in this indicator here. And with regard to carbonatite volcanic complexes, the idea is that near a rift tip, you may have carbonatite volcanism, whereas in a more mature rift, you're more likely to have alkali basalts. The idea being that if a rift here impinges upon cratonic lithosphere, which is thicker, you may have deeper melts leading to carbonatites, whereas in a more mature rift, you're more likely to get alkali basalts. So going back to Victoria and Rovuma, so here's Victoria with a rotation pole to the north. Here are alternative rotation poles. Here's Rovuma with a rotation pole to the south and alternative rotation poles. The model, as Anne showed earlier, suggests that there's greater extension here, which makes sense because it's further from the pole, as we showed earlier. And equally and oppositely, you have greater extension here at North Rovuma, because it's further from the pole. And these are just alternative extensions of those plates, but those opposite rotations. In this occasion, there's no nearby subduction zone, so it's unlike other cases of double saloon door tectonics. And I can only say that perhaps far field extension at this point would achieve this, but I don't have a geodynamic model for this. Further to this situation then, if we have these opposite rotations, we should have a propagating rift here, and we've just seen evidence to that effect, and a southerly one here. And that's like the double saloon door model, whereby if we have north one and south one fixed, they would be the equivalent of the Nubia plate. Victoria would be this north one rotating that way. Rovuma would be south, that's north two rotating that way, south two rotating this way. This rift would be Rukwa Tanganyika propagating north. This would be Malawi propagating south. And between the Rovuma and Victoria, rather than just having straightforward strike slip, we have a triangular rift here. Now, if we then look at seismicity on a DEM, the seismicity is concentrated in the rifts here. And this triangular rift here, comprising Kilombero, Kilosa, Ruvu, Rufiji, would be the equivalent of that triangular area between the two opposite rotating rifts. And further to that, there's greater seismicity here to the east, where extension may be greater than where this triangular rift impinges on Lake Malawi Rukwa system. So focal mechanism on Rukwa, Tanganyika, and Malawi show normal faults with extension northeast or east-northeast, but we do have strike slip at this zone where these two opposite rotating microplates interact, which is what we would expect. And that also occurs on the eastern branch, whereas if the faults are like this, you can get normal faults, but you can also get strike slip ones on faults that are oriented northeast, southwest. Returning to this seismicity and having a model where north one and south one are free to rotate like this and like this, you may create a rift here, and that would be the equivalent of the Luanga, Kariba, Okavanga rift. The difficulty here would be that this suggests northeast propagation, whereas the orthodox view is that this rift may propagate towards the southwest. And also, I suggested that it rotates counterclockwise, whereas Luke Wedmore et al. Have shown that the sand plate, which would be in this zone here, may rotate clockwise. And I see he's part of the crew today. So I'm a counter-orthodox view. So nearly summarizing, if we have Victoria plate rotating that way and Rovuma rotating that way, this is the triangular zone between the two, comprising Kilomberi, Closa, Ruvu, Rufiji, and possibly also Ruhuhu, where it impinges on Lake Malawi and Lake Rukwa. And those rotations are why we have unusual tectonics on the Sea Gap Ridge here, extending towards Dar es Salaam, Zanzibar, Pemba, and this part. Briefly, just a brief critique of this model that Anne showed earlier on. Excuse me that there's a critique of it, but this idea about the far field extension shown by large arrows and the idea that the rotation here is concentrated in the mobile zone rather than in the body of the microplate. I plotted earthquake slip vectors and GPS vectors at the same scale. And where this would look for northerly motion here, most of these are going northeast or southeast. And there's only two slow GPS that agree with this. And then over on this side, where you're looking for southwest or west-southwest motion close to the mobile zone, that's not what's shown here. So excuse me for the critique, but I just figured that was worth pointing out. So that's all I have to say. Double saloon door tectonics on the East African Drift, north propagation on Rukwa, Tanganyika, which is counter to the orthodox view. And why does that happen? I don't have a good geodynamic model for it, other than that far field forces close to the boundary between Victoria and Rovuma would end up doing it. And I leave you with a pretty picture of Njurungonga volcano and ask for your questions.
Thanks, Keith. Very good. Are there any questions from the audience? Okay, go ahead, Anne.
Thanks for the talk. I just wanted to respond to the critique because I was wondering in what reference frame the observations that you have are plotted, because I think they're not in the same reference frame, and therefore we can't really compare the directions of the velocities.
That may very well be, and excuse me if I have made an error in doing that. I was just plotting earthquake slip vectors published by people like Calais et al. And so on, and the GPS were from. Hey, I may well be making an error there. I don't.
I mean, it's not really an error. I just think that the velocity vectors from stamps, they are in the reference frame of Nubia fixed, while the sketch on the left is in like the model reference frame, which is not the same frame. So if you then remove the Nubia motion, so there would also be Nubia fixed, then it would correspond to the brown vectors that I showed in one of the slides, and then they match a lot better.
Okay, thanks, Anne. I think there's a question from Frank. I can see his hands raised. Go ahead.
Hello, yeah, thanks for the very nice talk. I had one comment on what Anna was saying, or the discussion. So I'm not sure if the figure is actually a good one, perhaps as a criticism, because both rift branches are opening. So the motion is perpendicular to the or should be more or less perpendicular to the rift branches, and therefore this arrow that's going parallel to the rifts seems to be a bit strange. Perhaps maybe something to look into and to think about. I just felt that was maybe a useful comment. I had another comment on the double saloon door idea. And that means that there should be a rift branch to the southwest, which is becoming larger and larger, farther away from the East African rift system. Is there any evidence for that? Is there a larger rift basin, let's say, going towards South Africa?
Yeah, you mean in the Luanga, Kariba, Okavanga rift?
I guess so.
That's the one that
next to the
extends
sun.
to the southwest from. Well,
Yes.
look here. That was a model allowing what I called North 1 and South 1 microplates to be free rather than being fixed. And I think therein lies the issue about that, because probably what happens is that there may be slight motion on that, but it's only slight motion. They're not perhaps completely free to rotate, because, as you say, otherwise it would be a wider rift to the southwest, and that's not really observed. There's X amount of rifting through that system. And then obviously also, Daly et al. Have suggested that it propagates in the other direction. And I see, and Luke Wedmore has suggested the rotation is a different way. I mentioned that only in the terms of that, if you do that, you have the rift in the right place, essentially, insofar as that opposite the Kilombero, Kilosa, Ruvu refugee system, you have the Luanga, Kariba, Okavanga system, and they abut each other. So it's a geographic thing rather than something else. And I understand that it's going against the orthodox view. My preference is for the model whereby North 1 and South 2 are more fixed than the ones to the east, because it's clearer that Victoria and Rovuma move relatively substantially in comparison to the potential relative movement of what would be rest of Nubia versus San.
Okay, I think it's interesting to talk about these. So thank you very much for this for this talk and these ideas.
Thanks, Keith. Are there any more questions? I think for Lauren, if you had one.
Yes, I actually have two questions, but I'll just quickly go through it. Thanks, Kate, for your interesting presentation and nice idea for sure. So I have two questions for you. One is the rift systems, the rift basins along the East African rift system. A lot of them do have multi-phase histories. You know, we know the region started to extend in the Karoo and has been reactivated in the Cretaceous, and it's again being reactivated again in present day. Mm-hmm. But I understand that your model is only presenting one, phase of extension, and I would like to know what your thoughts are on how multi-phase extension thinking is incorporated into your model. And the second question I have is, you're talking about the orthodox idea of the rift system propagating southwestward, and from my understanding and what I've seen so far along the East African rift system, we have in other rift systems in the world, it appears that we have to be careful to distinguish segment propagation from system propagation. These are different scales. A single segment can nucleate and propagate in, different direction or in single direction, depending on crustal structure, lithospheric structure. And I wonder what you think about that. Your model in that context of, you can, as you start to stretch the continent, you can nucleate many segments at the same time and they can propagate, right? And that's kind of different from the idea that the system is propagating in the direction.
Okay, listen, in answer to your first one, yes, the model is only related to the last piece of rifting. In other words, Neogene rifting rather than Karoo rifting, for example. I'm aware of the Karoo rifting, and I think that's part of the reason why I didn't show that slide here today, but in the paper I wrote about this, I included a map of the Kilombero, Kilosa area. And essentially, instead of having through-going faults, it's more like a network of faults, because some of the faults are inherited from Karoo rifting and from rifting of Gondwana when there was rifting off the Tanzanian coast. So you have a network of faults, which may be part of the reason why it isn't as clear-cut as it may be. And in answer to your second part about rift segments, I don't disagree that there are rift segments, and that there may be an overall system rift. And Frank Swan, who just commented a moment ago, has shown in some papers in that regard. And I think that is also reflected in the fact that in some of the evidence I showed, there's evidence for both north and south propagating segments within the western branch. But the point is this for me anyway, and that's why I started with my first slide. If you have a rotation pole and you rotate two microplates or plates about that, you tend to get propagation towards that rotation pole. It's geometry, it's Euler's theorem. And that's why there should be northerly propagation overall rather than individual segments on the Rukwa-Tanganyika system. And there should be southerly propagation on the Malawi system because of the poles of rotation in the case of Victoria being to the north and in the case of Ruvuma being to the south. Does that answer your question?
There's a lot more to discuss about this, but I'll leave it for now and we can chat offline.
Luke, can you ask your question? Luke.
Yeah, hi. Yeah, so I'm just going to comment on what Frank said, and so the evidence for the propagation of the Luangwa-Okavango system is that it is less extended the further southwest you go. So whether that's propagating that way or whether it's just lower extension, I'm not clear. But I was just going to say that it's a really interesting idea. But have you looked for any active evidence for active faults in the kind of to the east of the runway in that area which you say should be extending? Because I think that would be it's difficult from individual focal mechanisms to kind of confirm this hypothesis, but active faults would be perhaps more indicative, maybe. Well,
in answer to that, absolutely. If you look at, again, I didn't show it because I didn't have time. But if you plot earthquake epicenters on in that zone in Kilombero, Kiloso, and so on, loads of them plot on top of what look like faults just from Google Maps or Google Earth. Loads of them plot on zones where you see deflected river courses or other evidence for near-tectonics. So there's lots of evidence for near-tectonics in that zone. I don't have data or haven't worked on whether the focal mechanisms or so on support or don't support the thesis. So I can't comment about that other than the fact that there's plenty of evidence for near-tectonics in that area.